So this is 2025 paper 1 question 8, and basically we have a kayak which is priced at this, and we have two reductions. So it's reduced by 15% in the sale, and Jacob gets a further reduction of 10% on the reduced price. So first of all, let's find the reduced price. Well, that's going to be basically, it's going to be 85% of the original, which is 870. And another way you can think about that is it's 1 minus 0.15 times 870. So it's the original price, which is the 1, take away 0.15 of the price, and that's basically where the 0.85 comes from. And when you put that into your calculator, you get 739.5. Now, remember that Jacob gets a reduction of 10% on the reduced price. So Jacob gets basically 90% for the same logic of the reduced price, which is 739.5. Put that into your calculator, and if we put the correct units, it's going to be euros, and it's going to be 665.55, and that is the answer. So in the next part, there's a lot of things going on, but basically we have a paddle which objectively costs $95. Then we have two exchange rates. We have the one that Jacob thinks, and that's this one, and then we have the actual exchange rate, which is this one. And we're told that the paddle costs €1.02 more than Jacob thought it would. So the only thing, I guess the thing that jumps out to me here is that we can figure out how much Jacob thought it would cost because we know his exchange rate. So for Jacob, here's how it works. We have €1 is equal to $1.183. So if we want to figure out what is $95, well, first of all, we need to get dollar by itself. So you can treat this like an equation, divide both sides by 1.183. So €1 over 1.183 is equal to $1. And you could get a decimal on this, but I'm just going to leave it the way it is for the most accuracy. Now if I multiply both sides by 95, I'm going to figure out what $95 is according to Jacob. So multiplying both sides by 95, we get 95 over 1.183 is equal to $95. So now, in actuality, this is how much it costed in euros according to Jacob, but in reality, it was €1.02 more than Jacob thought it would cost. So in actuality, how many euros is it? Well, it's going to be 95 over 1.183, but it's €1.02 more than that. Okay? So this is the actual cost of the paddle. And we know that this actual cost is the same as $95, because it costs $95, that's a fact, and this is the actual cost of it, and that's equal to $95, pretty much. So this is the actual exchange rate, because we know for a fact that this is the real cost, and that's equal to $95. Now, they want it in the form €1 equals $D, so we need to just get €1 on the left side, so we can divide by this big bracket. So then, if we divide by that big bracket, we get €1 equals, because if you just divide this by itself, you get 1. So it's going to be $95 over, and then basically this bracket is in the denominator. Now again, you probably could have put decimal approximations on this. I just like to keep it the same for accuracy. So this is essentially what you get. So you have $1 equals $D. So this is what D is going to be. So you can just put that into a calculator. And what you get is you get D equals 1.1681, and the decimal keeps going. They say 3 decimal places. So we're just going to say D equals 1.168. They're not too strict about units here, but make sure that you don't put dollars on the units, because you can see there's already a dollar sign in front of D. So if you said D is $1.168, then that's like saying €1 equals like $1.186 squared, which doesn't really make sense. So D is just 1.168, sorry. And they're not too strict about units though, but just good to know. So then in the next part, we're told a few distances and some speeds. So basically, we're asked how long would it take him to kayak from S to A. So basically, the distance, we're going to use the fact that speed is distance over time, which is a fairly fundamental equation. So basically, the speed that he kayaks at is 6, the distance is going to be 2, and the time is what we're looking for. So we'll call this T, we'll call it TK because it's the time for kayaking. We also have to do running as well after this. So then TK will be equal to 1 over 3 hours. So let's bring the TK up to the top, then bring the 6 down, and 2 over 6 same as 1 over 3. Then let's see how much the running takes. So this is the kayak. Let's see how long the run takes. So for the run, the speed is 12. The distance is 8, and the time we'll call it TR. So this means that TR will be equal to 8 over 12, which is the same as 2/3. So we can say that the total time will be 1/3 hours plus 2/3 And again, this is in hours, sorry, TR, because everything here is in kilometers and hours. So a time will work out to be hours. And then when you add the two times together, you get a total time of 1 hour as your final answer. So then we're asked how long would it take for him to kayak directly from S to F. So you can see this is a right angle triangle. We can figure out the distance from S to F by using Pythagoras' theorem. So basically we have a right triangle with 2, 8, and I'll call this distance x. So we know that x squared will be equal to 2 squared plus 8 squared. So x squared will be equal to 4 plus 64 is 68, such that x is the square root of 68, which we'll just write as the square root of 68. It doesn't really help to write it any other way. Then remember that we all know speed is distance over time. So we're asking how long would it take for him to kayak. So that's going to be 6 kilometers per hour. And this distance is in kilometers, by the way, because the 8 and the 2 are in kilometers. So he can kayak at 6 kilometers per hour. He does a distance of root 68, and we're looking for the time. I'll just call it t. So that means that t will be root 68 over 6. And remember, this will be in hours. So we can simplify that slightly to be root 17 over 3. Now to convert this to hours and minutes as correct to the nearest minute, there's a button on the calculator that you can use. It kind of looks like 3 circles, and that converts a number into hours, minutes, and seconds. But if you're not sure where that is, we can also use another trick. So we can kind of treat this like algebra. So this is root 17 over 3 multiplied by hours, or an hour, I suppose. So it's root 17 over 3 hour. But then we can replace hour. 1 hour is equal to 60 minutes. So we can actually replace hour with 60 minutes. So then we can replace, we'll have root 17 times 60 all over 3 mins. Because multiplication is commutative, we can just take this 60 and multiply it by this stuff, and then figure out what this is to whatever decimal places. And when you do this, what you'll get, if you put it to decimal, is you'll get 82.46 minutes. So then to the nearest minute, you can say that that is 82 minutes, or you could say 1 hour and 22 minutes, and both of those are correct. So then we're given a new diagram, and we're told that he's going to kayak from S to B and then run from B to F, and we're asked for the total time. So let's first of all look for the time for the kayaking. So we have to figure out what the distance from S to B is, and again we can use Pythagoras' theorem. We have 2x, and then we're going to have, this is the distance SB, so the distance SB squared will be equal to 2 squared plus x squared. So that means that the distance SB will just be equal to the square root of 4 plus x squared. Then remember that speed is equal to distance over time. So remember that the speed for kayaking is 6 kilometers per hour. So we can say that 6 will be equal to the distance, which is root 4 plus x squared all over time, which we can call it tk. So that means that tk will be equal to root 4 plus x squared all over 6. So that's the time for the first part of the journey. They want the total time, sorry. So now we need to figure out how long does it take for him to run from B to F. Well, we need to figure out what this distance BF is. Well, we know that the entire thing is 8. BF is the entire 8 without the x, so this distance here is 8 minus x, which makes sense because if you add this to this, you get 8. So that makes sense. So basically, for the time of running, speed is distance over time. The speed he runs at, I believe it was 12 kilometers per hour. Yep. So we're going to have 12 equals, and then the distance is going to be 8 minus x, and the time, we're going to call it TR. That means that TR is going to be 8 minus x over 12. So the total time, capital T, will be TK plus TR, just adding the two times together. So if we take TK, that's going to be root 4 plus x squared all over 6 plus 8 minus x over 12, and this time is in hours. If you want, you can combine this into one fraction. So if we multiply the top and bottom of this fraction by 2, that would give us 2 root 4 plus x squared, and that's over 12. So we can combine these together, plus 8 minus x all over 12. But they don't ask you to write in a certain way, so the first way is, either way is fine. So then basically what they do is they differentiate it for you, and they set that equal to 0, which allows you to find the local maximum or minimum, in this case the local minimum. So I guess a way that you could check your answer here is if you differentiate it and you get this, then you know you're correct, but you didn't have to differentiate it, so we can actually just solve this for x here. So what we can do is we can bring the 112 to the other side, so we're going to have x over 6 root x squared plus 4 is equal to 1 over 12. And then we could probably multiply both sides by 12. I'll do this in steps. So I'll multiply both sides by 12, and we'll get 2x over root x squared plus 4. That's because the 12 comes up here, and 12 over 6 is 2, so just cancel that out, and then we get that's equal to 1. So that means that 2x is equal to the square root of x squared plus 4. Now we can square both sides. Don't forget that when you square the left side, you square both things in the bracket, so you get 4x squared, and that's because these two things are multiplied together. It's like 2x times 2x, which is 2 times x times 2 times x. So 2 times 2 is 4, and x times x is x squared. Multiplication is commutative. The order doesn't matter. So we get x squared plus 4. When we square the square root, it just goes away. That means that 3x squared is equal to 4. Or in other words, x squared is 4 over 3. So that means that x is equal to 2 over root 3. Well, I guess, or you could say the square root of 4 over 3, but that simplifies to 2 over root 3. And we know that x is a positive between 0 and 8, so we don't have to worry about the minus answer. It's going to be just that one. And then they say correct to 3 decimal places, so we're going to write x equals, so it's 1.1547, so correct to 3 decimal places, that'll be 1.155 rounding up. So that's our value for x. So then we're given some graphs and some information. So we're told that there's no other values of x for which t prime of x equals 0. So that means there's no other maximum or minimum. So that immediately excludes a and b. So first of all, we can say justification, it's not a or b because there's only one x for which t prime of x equals 0. So the fact that this has a minimum and a maximum, and so does this one, that can't really be the case. The only difference then between graph C and D, other than that, if you have a look at it, is that graph C starts higher than it ends, and graph D starts lower at the start and ends up higher. So basically, we know what the start point is, it's 0, and the end point is x equals 8. So we can just calculate these and see which one's bigger. So basically, let's have a look at what is t of 0, because this is the graph of t of x. So what's t of 0? Well, again, we can just sub in 0 into our function. So here's our function for t. So t of 0 will be this thing with the zeros subbed in. So when you sub in x equals 0 there, you will get 1. And if we then do t of 8, so that means t of 0 is kind of the starting point over here. T of 8 is going to be the ending point. So let's sub in x equals 8. So when you do t of 8, you should get about 1.37. So clearly, the ending point should be higher than the starting point. So that means it must be graph D. So we can answer that it's D. So then we also know that t of 0 equals 1, and t of 8 is approximately equal to 1.37. So t of 8 is bigger than t of 0, which is only true in D. In C, t of 0 is smaller or bigger than t of 8. So it can't be C. Just trying to justify it as much as possible. And yeah, that's the end of the question.